Here's integrated 3. It is CL10-203. It says from the ground, a rubber ball is launched 20 feet into the air. If its rebound ratio is 7/10, how far will it have vertically traveled after the first 5 bounces? So that one, I like to draw a picture because that it's kind of hard for me to just plug the numbers into the formula without understanding what they are. So I kind of drew a little picture. I tried to just imagine, okay, it got tossed 20 feet in the air and then it came down. So it's already gone 40 feet before it even bounced. Like this is it bouncing the first time. This is a 1. I had it messed up at first. I decided to call this 0 because it hasn't bounced yet. And then this is 2, 4, and 5. Okay, so I just made a picture just to make sure I was going to plug the right numbers in here because I actually did just plug some numbers willy-nilly right into here and got it wrong, and then I had to go through and draw it. So here it hasn't bounced yet, but it's traveled 40 feet. It says, the problem says after the first 5 bounces. So I think they want you to include that 40 and then it bounced 1, 2, 3, it bounced 1, 2, 3, 4, 5 times. Oh, I guess I gave up on writing these out, but I guess that'd be the 4th and the 5th. Okay, it bounced 5 times. So I just went and I wanted to, well, I know the formula is going to be 40 times 0.7, because, well, 0.7 is 7/10 to the n, and I decided to start at 0, and I think I just decided that to start at 0 because I think I'd looked in the answer key and they started theirs at 0. You can start at 1, but then you have to adjust things so I started at 0. And I go to 0 from 0 to 5, and then I tried by just plugging a 5 in there and plugging R and A. I used A as 40, and it was a little bit off. But then I realized N, this is the sum of the bounces after the sum of the distance after the first n terms. Well, really, even though I'm only counting up to 5, since I have that 0 in there, there's really 1, 2, 3, 4, 5. There's 6 things I'm trying to add up. So you need to use a 6 here. And this formula, by the way, so that's a little confusing, I guess. The bouncing, whenever it's a rebound problem. The formula just came from this math notes box on geometric series. I just used that one. The total sum for a finite geometric series. Okay, so that's where I got it. But then I had to use it correctly. So, and I even actually, I saw that your answer book did it a little bit different than I did. They, 203. They set theirs up, like they didn't put the 40 there. They took a 2 out, but it'll still give the same answer. I guess they're thinking about because the initial throw was 20 or whatever, but the way I drew my diagram, I like to think of it as comes up, what goes up must come down. I just thought it was more simple to just think of it as, 40, but then it's adding up to smaller and smaller numbers. And it wasn't very hard. I made a table. 40 plus this right here, 40 times 0.7 is 28, and 40 times 0.7 squared is 19.6. And I actually went through and added these all together because I couldn't believe that when I plugged the numbers into my formula, I couldn't believe it gave me a different answer, and I thought the answer key was wrong. But these do add up, and my picture is correct. and they add up to 117.6, the problem is you know that you need a 6 in here because this is formula minus r to the n 1 minus r. Okay, this is the formula that I just showed you a second ago in the math notes box. So I took my first term, which is actually the 0th term in this scenario. That's what A is. And then I used my bounce ratio, which was 0.9. And then n, since there were 6 terms, like when I drew the picture, you could see there were 6 terms. That's why I raised my bounce ratio to the 6th power. And then 1 minus 0.7, because remember 0.7 was our bounce ratio, our rebound ratio. So that's the 0.3. And then if you'd put that in your calculator, it works. So probably that was the long explanation for why didn't your formula work. It's because you needed a 6 right there.